All right, we should be recording. So we have this example. We have 3x sub 1 plus 4x sub 2 is equal to 1. It's over just a little bit. It's on the screen. And we have x sub 1 minus 2x sub 2 is equal to 7. And it should be in focus now. Now, we want to solve this basically using row operations and putting this into a matrix. So you'll notice that this is the coefficient matrix, would just be the coefficient variables there. And then we're going to augment on the constant matrix, which is going to be 1 and 7 there. Now, when we solve these systems in matrices, we want to basically get this to be a 1 here, a 0 here. And if there were more rows, more like columns, I should say, we'd have zeros all the way up to whatever the last number is, the constant. Because this basically tells us x sub 1, x sub 2, and then this is the right-hand side. In other words, if you have a 1 here and 0 here, that would tell you that basically you have an x sub 1 equal to something. So here, let's go and solve it, and then we'll translate it out. So in this case, I want to get a 1 there, so I'm going to swap row 1 with row 2. So that means it's going to be 1, negative 2, augmented on matrix, 7, like that constant part. And then this will be 3, 4, and 1. Now, the next thing that I want to do is get a 0 here. So I can do that by doing negative 3 times row 1 plus row 2. So, and I'm going to go down here just so that way you can follow along where I'm going with that. And generally, I like to write what I'm doing to whatever row right after it. So in other words, this would technically be applied to row 2 is what you'd be thinking. I don't always write that arrow part, but I write it right next to the row that I'm doing that operation to. So top row still stays the same. Bottom row now, that 3 becomes a 0. That was the whole point of why I did that. Negative 3 times 1 plus 3 gives me 0. Negative 3 times negative 2 is positive 6. Plus 4 gives me 10. Negative 3 times 7 is negative 21. Plus 1 gives me negative 20. Yep. And so now what I need to do is I need to get a, so there's now zeros below that 1. I need to now get a 1 here and then zeros above and below it if this had been a bigger matrix. And in this case, I just got to get a 0 above here once I have this to be a 1. Yeah, I can multiply this by 1/10 times row 2 becomes the new row 2. And generally, like I said, I don't always write this, but your textbook will write it. A lot of other places will write that notation. 0, 1, right? 1/10 times 10 is 1. And 1/10 times negative 20 gives us negative 2. And the top row is still the same. And we have that. Now what we need to do is get that to be a 0 above there. So I want a 0 there. And this becomes, so maybe we'll do what? 2 times row 2 plus row 1 becomes the new row 1. Yeah, that's right. So once we do that, we'll have basically this 0 times anything 0. So 0 times 2 is 0. Plus 1 is still 1. That's the nice part about that. 1 times 2 is 2. Plus negative 2 gives me 0. And that was the whole point of why I did that. 2 times negative 2 is negative 4. Plus 7 is 3. That's right. And then we got 0, 1, and negative 2. Now, we have solved this system of equations up here. So in fact, x sub 1 is equal to 3, and x sub 2 is equal to negative 2. Because think about it, this is x1, this is x sub 2, and this is the right-hand side, or you can think of it as the numbers, whatever way you want to look at it as. Bottom line, if you were to translate this right here, this whole column, or this whole row, I should say, this is 1 times x sub 1 plus 0 times x sub 2 is equal to 3. And that's why I just wrote it this way, right? Because there's no reason to write that, but I just want to make sure you understand that 0 is technically a coefficient in front of x sub 2. So that would be the same thing down here, where you'd have actually 0x sub 1 plus 1 times x sub 2 is equal to negative 2. But hence, I still just write it that way. Now, if you're ever in doubt whether this works, you could always go back and plug it in here and check. So that means, let's check that first one. We'd have 3, right? This is x sub 1 plus 4 times x2. Well, x sub 2 is negative 2. Does that equal 1? All right, so 9 plus negative 8. Yes, that equals 1. Check. So you see that that works. Awesome.